Here nitric acid preparation is given in these 3 steps, and it's clearly mentioned that the percentage yield is 50, 60 and 80 for these 3 steps respectively. And now we need to find out what is the volume of ammonia required at STP in order to produce 1575 grams of nitric acid. So as the equations are clearly given, and definitely it is easy but involves more number of stages because we need to interlink all the 3 equations. So here we need to find out the volume of ammonia required to produce this many grams of nitric acid. So it is 1575 grams of nitric acid means 1575 by 63, which is equal to 25 moles. So we need to prepare 25 moles of nitric acid. Let's see. Now from the first equation, it is very clear that 4 moles of ammonia gives rise to 4 mole of nitric oxide, isn't it? So here it is in the ratio of 1:1. So as in the first step the yield is given as 50%, so definitely from 4 moles of ammonia the number of moles of nitric oxide formed are only 2 moles, isn't it? So this is our first step. Then in the second equation, 2 moles of nitric oxide, this one gives rise to 2 moles of NO2. So it is a continuation of this one only. Now here this 2 moles of nitric oxide is involved. As the yield is 60%, how many moles of NO2 are formed? So it is 2 into 60 by 100. It is nothing but equal to 1.2 mole. Now the third one, 3 mole of nitrogen dioxide is required in order to give 2 moles of nitric acid. But in this step we got only 1.2 mole of nitrogen dioxide. So when 1.2 mole of nitrogen dioxide is involved, first calculate how many moles of nitric acid will be formed. It is nothing but 1.2 by 3 into 2 moles of nitric acid. But in the third step, it is given that the percentage yield is 80%. So definitely it is 80% of this particular value. And now on calculating, this becomes 0.64 mole of nitric acid. Means from 4 mole of ammonia, we are getting 0.64 moles of nitric acid. So to get 0.64 mole of nitric acid, we require 4 mole of ammonia. And in order to get 25 mole of nitric acid, which is the given value in the numerical, that is 25 mole of nitric acid, how many moles of ammonia is required? It is 25 by 0.64 into 4. That one we will get it in terms of moles. As we require in terms of volume at STP, we need to multiply this one with 22.4 liters and we will be getting the final answer as equal to 3500 liters. So our answer is option B. Is it clear? From the equation, first we calculated the number of moles of nitric oxide formed. Along with it, by considering the percentage yield, from that value we calculated the number of moles of NO2 formed. Again by using a 60% yield, and from that we calculated how many moles of nitric acid formed, and that too with 80% yield. So we are getting this much quantity of nitric acid from 4 mole of ammonia, and we require 25 mole of nitric acid. So how many moles of ammonia we require? Convert that one into volume by multiplying with 22.4. You get the final answer.